representing real numbers on the number line. In the previous section, you have seen that any real number has a decimal expansion. This helps us to represent it on the number line. Let us see how. Suppose we want to locate 2.665 on the number line. We know that this lies between 2 and 3. 2.5 will be here 2 and here it is 3, so in between 2.5 will be there, and here 2.1, 2.2, 2.3, 2.4, 2.6, 2.7, 2.8 and 2.9. so here 2.665 will be there in between the 2 and between the 3. Again 2.665 will be here in between the 2.6 and 2.7. So here it is the 2.65 and here it is the 2.66. In between it will be the 2.65. So let us look closely at the portion of the number line between 2 and 3. Suppose we divide this into 10 equal parts and mark each point of division as in figure 1.11a. Then the first mark to the right of 2 will represent 2.1 and the second 2.2 and so on. You might be finding some difficulty in observing these points of division between 2 and 3 in figure 1.111. To have a clear view of the same, you may take a magnifying glass and look at the portion between 2 and 3. It will look like what you see in figure 1.112. Now 2.665 lies between 2.6 and 2.7. So let us focus on the portion between 2.6 and 2.7. Seeing figure 1.121, we imagine to divide this again into 10 equal parts. The first mark will represent 2.61, the next 2.62, 2.63 and likewise 2.69 and 2.7. So now 2.665 lies between 2.6 and 2.7. So let us focus on the portion between 2.6 and 2.7. See figure 1.121. We imagine to divide this again into 10 equal parts. The first mark will represent 2.61, the next 2.62 and so on. To see this clearly, we magnify this as shown in the figure 1.122. Here again we will 2.6 will be here and 2.7 will be here. Again 2.66 will be there and 2.6 will be there. 2.65 will be there. Again 2.65 will be there, and what you have to 665 you have to show. Again 2.665 lies between 2.66 and 2.67. So let us focus on this portion of the number line. See figure 1.131 and imagine to divide it again into 10 equal parts. We magnify it to see it better as in figure 1.132. The first mark represents 2.661, the next one represents 2.662 and so on. So 2.665 is the fifth mark in these subdivisions. 2.6 and 2.7. You can see here the figure 1.13. We call this process of visualization of a representation of numbers on the number line through a magnifying glass as the process of successive magnification. So we have seen that it is possibly by sufficient successive magnification to visualize the position or the representation of a real number with a terminating decimal expansion on the number line. Let us now try and visualize the position or representation of a real number with a non-terminating recurring decimal expansion on the number line. We can look at the appropriate interval through a magnifying glass, and by successive magnification visualize the position of the number on the number line. Example 11. Visualize the representation of 5.37. A bar is on the 7 on the number line up to 5 decimal places, that is up to 5.37777. The solution is once again we proceed by successive magnification like this, and successively decrease the length of the portion of the number line in which the 5.37 is located. First we see that the 5.37 is located between 5 and 6. In the next step we locate 5.37 bar between 5.3 and 5.4. To get the more accurate visualization of the representation, we divide this portion of the number line into 10 equal parts and use a magnifying glass to visualize that 5.37 var lies between 5.37 and 5.38. To visualize 5.37 var on the 7 more accurately, we again divide the portion between 5.37 and 5.38 into 10 equal parts and use a magnifying glass to visualize that 5.37 lies between 5.377 and 5.378. Now to visualize 5.37 bar upon 7 still more accurately, we divide the portion between 5.377 and 5.378 into 10 equal parts and visualize the representation of 5.37 bar on the 7 as in figure 1.144. Notice that 5.37 bar on the 7 is located closer to 5.3778 than to 5.3777. See the figure 1.144. You can see here in your book how it is being represented on the number line. Visualization is there, magnification is also there. Now remark, we can proceed endlessly in this manner, successively viewing through a magnifying glass and simultaneously imagine the decrease in the length of the portion of the number line in which 5.37 is located. The size of the portion of the line we specify depends on the degree of accuracy we would like to for a visualization of the portion of the number on the number line. You might have realized by now that the same procedure can be used to visualize a real number with a non-terminating, non-recurring decimal expansion on the number line. In the light of the discussion above and visualization, we can again say that every real number is represented by a unique point on the number line. Further, every point on the number line represents one and only one real number. Now exercise 1.4 you have to solve. Next point will be the 1.5.